Hi, everyone. Welcome to the Power Hungry Podcast. I'm Robert Bryce. On this podcast, we talk about energy, power, innovation, and politics. And I'm pleased to welcome Kelly Wanser. She is the executive director of Silver Lining, which is a nonprofit that is dedicated to ensuring that society has information and options to address near-term climate risk. Kelly, welcome to the Power Hungry Podcast.
Thanks very much for having me, Robert. It's a pleasure to be here. I enjoy your show.
Well, thanks. Well, so I warned you. Sometimes I ambush guests, and I don't warn them, but I warned you that the guests on the Power Hungry Podcast introduce themselves. So I've mentioned what Silver Lining is. If you don't mind, imagine that you have about a minute. You've arrived somewhere. You don't know anyone. You've just arrived, and you are asked to introduce yourself. Please go ahead.
Thanks. I'm Kelly Wanser, the executive director and founder of Silver Lining. My background is in the technology sector, and I worked for many years in IT infrastructure and networking, and with particular focus on complex systems. So I became concerned about climate change about a decade ago, a little bit longer, and particularly some of the signals that we were seeing that the climate system might be changing in ways that we don't understand very well. And so I'm coming to climate change from the point of view of the information and risk problem that we have, where there are some things that we know. And one of those things is that the climate system is projected to continue to warm no matter what we do for several decades. And we could talk more about that. But I was very interested in that problem because there's a mismatch between what we know about the climate system continuing to warm and what we don't know about what the consequences of that would be, and what we don't know about what our options might be to reduce warming quickly if we needed to. So I started looking into these questions with scientists about a decade ago, and about 4 years ago started Silver Lining to explore them further and really to try to drive forward how quickly we might develop information options to address some of these open areas of risk.
Right. So the term that you use when you talk about these issues, you prefer the words climate intervention, not geoengineering. I've had a guest on the podcast, David Keith, who we talked about. We use the term geoengineering. But before I get to that, I want to just show a little bit more about Silver Lining. I looked you up. I know how to use GuideStar. I didn't see your Form 990, but it appears your budget's about $3.6 million a year. Is that right?
That's right. It's increasing slightly, and it varies a bit because we also raise funds for research. So some of that money, in fact, quite a bit of it, we've given out directly for scientific research grants. And we're a bit like a medical foundation. So we support cutting edge research directly and try to help scientists in the field. And then we also engage in policy work and public and civil society engagement to try to move the issues forward.
So you're funding research, and you're an advocate. Well, nonprofits aren't supposed to be advocacy organization, but education.
We are.
Oh, okay. Well, you're advocating for climate intervention, for I'll say the word geoengineering. If you don't mind, I'm going to just
one quick thing, because we're not advocating for climate intervention. We're advocating for more research and better information
to understand what it might be and how it might work.
If you think about the problem like COVID, where you have this sort of fast moving public risk, and you're looking at, you want to look with clear eyes at what solutions might be on the table to address that. That's how we think about these climate interventions. Is right now, we actually don't have enough information to know whether they're on the table. But the level of information we have is too low, and it needs to be increased really fast.
I see. Well, that's interesting as you say that, the idea about the vaccine, because you've used this term emergency medicine several times. So I guess if you were thinking about a big problem like a pandemic, and you have money, you'd fund vaccine research and try and figure out how you tell the public about the vaccines and whatever else. So just a thought occurs. And so
how you help set up the systems for, in the case of vaccines, we have pretty strong systems for looking at new medicines and how they work, but they had to adapt those a little bit because they had a fast moving problem. So in this case, as far as planetary medicine or, climate scale medicine, we're behind in terms of having those systems to really evaluate these things.
And that's one of the things I want to talk about because the system is so complex. And one of the things that to me is interesting about what your work is and why I had David Keith on is that I don't have necessarily strong feelings. I don't know that much about geoengineering, except that I just know that the atmospheric systems are incredibly complex, right? And so that's
Right.
one of the difficulties in even thinking about these issues. But one other quick question, just on the kind of the basics about silver lining. So where does your funding come from?
So we have funding mostly comes from individuals and small foundations. A lot of them have their origins in the technology sector, or folks who come from complex systems backgrounds, usually at the intersection of philanthropists who are, have some background in technology or finance and are working on climate change.
Okay.
And so people who kind of understand these sort of complex problems in a way that might lend itself to innovation and research, but people who are interested in climate change.
Gotcha. So any foundations or entities that we'd recognize in terms of that funding?
Probably not in terms of, household name type people. We have most of them listed on our website, the individuals and foundations.
Gotcha.
So if people can kind of check that out.
Sure. And again, that the website is silverlining.ngo is the website for Kelly's group, Silver Lining, which is part of the Silver Lining Foundation, I guess, is if you want to look them up on GuideStar. But I want to quote from the piece you wrote in The Hill in December about what you're working on, and I think this is the paragraph that sums up what we're talking about here. You wrote, climate intervention might provide emergency medicine the world needs. The most rapid and scalable approaches involve increasing the reflection of sunlight from clouds and particles in the atmosphere, a phenomenon that already occurs when large volcanoes erupt or particles from emissions brighten clouds, a cooling influence on climate today. The idea is to emulate these effects in cleaner and more controlled ways to keep human and natural systems stable while society reduces emissions and transitions to a more sustainable future. So we've already talked about emergency medicine and that idea, and I think that's an interesting parallel. But the idea is to emulate these effects in cleaner and more controlled ways. There's a lot of controversy around this already. I mean, the ideas, including, I want to talk about what happened in Mexico, right? I guess this guy was kind of freelancing, and they launched some balloons to do some things, but how do you even do the experiments here? Because that seems to me one of the biggest problems that David Keith talked about was that, they want to do these trials and try and figure out how effective something, these experiments might be. But from everything that I see, even getting the permission from different countries to do it is hard. Am I missing something?
Well, that's where we think it actually matters how you talk about it and how people understand the context. So one of the challenges of the term geoengineering is people think it's about engineering. And they think, that in the act of doing what are effectively very small things to learn about the science, that you're actually out there, quote, engineering the planet. And it's really a hard distinction to draw. If people are sort of saying, well, yes, we want to geoengineer the planet and we're going to start sending up balloons or what have you. And so really trying to ground people in what context you're in. So one of the reasons we like to talk about what's already happening is that right now today, all over the world, ships, coal plants, factories push particulate emissions into the lower atmosphere. And those emissions are mixing with clouds in ways that make them brighter. And the big scientific bodies, especially the UN, have said, and it's in their charts, this is cooling the planet. This is masking some of the warming. It's pushing more sunlight back to space at a planetary scale. We think it's around 0.5 degrees Celsius, but our range of uncertainty is about 1 degree. So what that means is, whatever context we're thinking about this in, one aspect of it is right now we're already doing a version of this, and we're doing it in a very dirty, uncontrolled, sort of uncertain way. And so helping people to see hey, this isn't something brand new that, David Keith and others are pulling out of the box, or the balloon guy in Mexico. There's a phenomenon that's happening that's a function of our pollution that we don't understand very well. And the research that we need to do is to understand what's already happening, and then to see, hey, is this something you could leverage to create a safer profile than the warming we've got locked in? And so, thinking about it that way versus thinking about it as this science fiction concept, of sort of engineering and super fast and all of this, it's really just like how people start to wrap their heads around it is part of the reaction to these small experiments. I mean, it's really unfortunate that the balloon guy in Mexico, because he's buying weather balloons off of Amazon. He's putting 5 kilograms of gas in them. Those things pop, like nothing's probably at all happening, and he's not doing any science. And so it's really, in terms of its actual practice, kind of a big giant nothing burger. But it's
it's gotten maybe nothing burger maybe, but it got enormous headlines. The Mexican government has since passed I don't know whether it was the Mexican Congress passed something, the Congreso, or what happened there, but they've said no more of this. We're not going to permit any of this. And I guess
and what is sort of I don't know what you call those big Texas Roundhouse, like 2-pound burgers that they bet you can't eat, but there is one of those.
We're going from the what is it, the ionosphere to Big Tex Steakhouse in Amarillo.
Yeah,
okay, so
I'm a climate person using meat metaphors here. I don't know about that, but what's really substantive there is he is selling credits. And, there's always somebody who will buy something. And so
wait, I want to understand I don't know his name. It was the Make Sunsets was the outfit's name, right? The guy in Mexico. So he was selling credits. I had no idea.
Credits. Yeah. Wow. Yeah. And I don't really advertise for him here, but, basically you have in the climate change, the concept of, is there a market model for pulling greenhouse gases out of the atmosphere, and you have these emerging markets for credits to do that, these carbon credit markets. And so he's gone conceptually a step further to say, well, hey, notionally, if you put X amount of sulfate at Y altitude in the atmosphere, you get Z amount of sunlight reflection, and therefore I'm going to create a cooling credit and charge people for that, and then they can pay to help me cool the planet and scale things up that way. And so there are a variety of problems with that. The most immediate problem is what he doesn't do anything, and he's not measuring it anyway. And so there's just a whole level where what he's doing is sort of in the frame of fraudulent.
Is in the frame of, I'm sorry, what?
Being fraudulent.
Fraudulent. Okay. Yes.
Yeah. So, but the bigger issue, the big burger, is that the idea that there's an open market concept where companies could spring up and push what's effectively pollution into the atmosphere and earn some kind of credits, and people would be incentivized to do that. And there are a lot of really big problems with that concept. Among them being that right now, we, like I said earlier in the conversation, that we don't have enough scientific information to know whether this is a good thing to do or not. And we definitely don't have enough scientific information to quantify it at that level.
Or to create some kind of a market, right? That would, as you say, X equals Y equals Z, that would have some clear payback for people buying these things or whatever. So, but go ahead.
Yes, but there are voluntary markets today for carbon credits, right? So these things are springing up partly as a sort of, some people call it greenwashing, or, way of looking like you're compensating for your climate impact and things like that. And so it's possible that something like that could happen here fairly quickly if people got that notion. And that would be really unhelpful, and that's something people are right to be concerned about.
The right to be concerned about the fraud, their right to be concerned about the lack of understanding of the science, their right to be concerned about any kind of international cooperation permission? I mean, look, I don't want to come off as super skeptical, but I also, when I look at what the ideas around climate intervention, I just think, well, and I saw your TED talk, and you mentioned ozone. I'm kind of skipping around here, and you talked about the Montreal Protocol and that how effective that was. And I agree, that has been effective, but it is one of the few one-off examples where we truly have international cooperation. And it's one of the things where I think about issues like this or CO2 emissions reductions, and I think, well, how are you possibly going to get international buy-in when we don't even have international agreements to ban landmines? I mean, that seems like it should be an easier one, right? So let me ask that question then directly. Right. How do you get a framework in such a complex political environment now globally, right, that would have buy-in from a significant number of countries who would say, sure, let's try this? And how do you, because that is that the biggest challenge you're facing? Because you're going to have some kind of international agreement, aren't you?
So that great question. Really great question. I'll put a slight angle on your question in the sense that, sure, not trying to get international agreement on let's try this, but trying to get international agreement on let's study this and figure out how we make decisions about it.
Okay.
And so,
and how's that going? Because the study first, experiment later. Then is what your first things first.
Well, experiments are part of study.
Okay.
So if you think about how big, go outside and look at a cloud, right? Because I work with the people who are thinking about like how you would influence the cloud. These clouds are massive. In the experiment that they want to do is like less than what comes out of a smokestack, right? And even in the atmosphere, like a proper upper atmosphere experiment would involve basically the contrail of an aircraft. And of course, we have aircraft going all the time.
And that's 40,000 feet over the surface, something like that.
For the stratosphere, you would go higher. So you'd go upwards of 60,000 feet.
Okay.
But so if you think about what scientists are saying, which is we want to do this at the level of one plume, right? And every day around the world, we have probably trillions of plumes of stuff blowing into the atmosphere. And they want to go and do one plume and study it carefully because they need this sort of control example. And then they take what they study and they plug it into models. And that helps them not have to do something bigger that they don't understand before they do it. And so the objection, so what you want is these little studies going on and they feed into the other science and the modeling. And then the scientists look at all of that and kind of like medicine again and say, okay, what does this do to this part of the system? What does this do here? And how does the patient land? And so you want all that going on in the functions that they have. If you take the Montreal Protocol, they have this really robust scientific assessment function. And they just released their report on the state of the ozone. And I'm going to say something like non-diplomatic, but what's wonderful about them is they're not fucking around. Their scientists are totally independent. The politicians do not affect what the reports say, which is not true of the other bodies. So if you take the IPCC, who publishes the climate reports, the national actors have some influence on what those reports say. And so in the Montreal Protocol, you have this very rigorous science process where they've always been oriented around, look, we can't let the ozone layer fall outside of certain bounds. And we're real serious about that. And so we're going to observe it. We're going to do the science. We're going to tell the policymakers what's what. And then they have to figure out how to comply. It's rare, but it works. And so what's interesting to the point of your question is they actually stepped forward on this issue because the form of climate intervention that's most prominent involves putting things in the stratosphere that could affect the ozone layer. So they just published for the first time anywhere in the world, a whole chapter on this in their ozone report, which is actually the most.
And you're talking about the Montreal Protocol now, just to be clear. Okay.
Yes. And so they, at least for looking at this stratospheric version, this very high altitude version, which is the most sort of prominent form and probably the most accessible, although not as easy as your balloon guy would make it out to be, form, that body actually has some jurisdiction over it already.
Well, that's interesting. I didn't realize the Montreal Protocol would have some jurisdiction there. And when you're talking about stratospheric particles, so we're talking about the 60,000 feet above the Earth. So what would it be, 15 to 20,000 meters, something like that?
That's right.
What I understood from David Keith, although we didn't talk for a full hour, was that his idea, or the one that he had been working on, was using sophisticated airplanes like, Gulfstream 5s, or, the latest G6 or whatever it is, that can climb to that level of the atmosphere. And then they would release this. And I know we talked offline or exchanged emails about crop dusting, but I've seen crop dusting planes. That's kind of what I think about, that they're going to,
okay.
they're going to spread these particles at that level in the atmosphere, with the idea that is going to reduce solar radiation hitting the Earth, and that would act as, for lack of a better term, some kind of a particulate umbrella, right? Or parasol, right? That would then reduce the amount of solar radiation on the Earth. Have I got this correct? Am I?
You do, yeah. In fact, we have a really esteemed scientist that calls it the aerosol parasol.
Okay.
And he's referring to all the aerosols in the atmosphere, because when you look at the Earth from space and you see how it shines, that's what that is. Sunlight bouncing off the particles in the atmosphere, in the clouds. So
is that how then we should? I mean, I like that. Well, it rhymes, of course, and so I'm just
aerosol
parasol. So is that kind of the gist of the idea of climate intervention, and why? And the other thing that comes to mind as I'm thinking about this, and again, spitballing with what very limited knowledge that I've gained in looking at your website and what you've written, why wouldn't we? The other thing that seems obvious to me is, or obvious, or maybe a little easier than having jets flying at such high altitude. What about this other idea I've heard about, putting big boats in the ocean to make clouds, to evaporate water and make clouds? Would that be lower cost? Is the payoff not as much, or is that a different approach to this same problem, or am I completely
it's a different approach to the same problem with different characteristics. And one of the reasons I really like to talk about medicine, because it's very helpful context when you think about different medical treatments, and they have different risk benefit or side effect efficacy characteristics. So in the high atmosphere, in the stratosphere, they've observed what happens when large volcanoes go off. The stratosphere is what scientists call very uniform. So stuff gets up there, it gets entrained in these really fast winds and moves around, and everything in the stratosphere is pretty consistent. Low atmosphere is very, as we know, very heterogeneous. I can have a massive storm over here and no clouds over here, and lots of currents and atmospheric phenomena going on. And so the characteristics are really different. So in the stratosphere, if I put material there, it stays about 1.5 years. And it entrains down very slowly. And what I'm looking to do up there is maybe increase the reflection of sunlight by about 1% in a relatively uniform way. So it's not something that people would experience visually, unlike, what some people say about blocking the sun or dimming the sun. It's already happened. It happened in 1991. When Mount Pinatubo erupted, and nobody noticed on the ground, but it did cool the planet for a 1.5 years. And so one of the reasons early scientists like David and others like this is that they're pretty confident that they know something about what level of cooling you can get when you do it, which is part of the reason why the balloon guy is trying to sell credits, because he's just doing very basic math based on that kind of calculation.
And to interrupt, forgive me, I interrupt a lot, and sometimes
I talk a lot, so that's good.
I get some comments on the podcast say, "Would you shut up? You interrupt."
No,
all the time.
I need people who interrupt me. I'll just keep going.
But I want it to be more conversational. But the point that you made there is interesting. That what I heard you say, I'm repeating it back, is that our understanding of the stratospheric aerosol parasol is far greater than our understanding of what would occur in the lower atmosphere, and that it's a more stable environment if we're going to put stuff up there than it would be if we tried to create clouds closer to the surface. Is that fair?
I'll talk about it. Great question. Because I think on the efficacy side, on the benefit side,
the bang for the buck effort. Yeah.
Well, just a good handle on how much cooling you get and how that works. There's still a lot to know. Like, for example, it because the models didn't represent this until we started funding, helping their evolution the past couple of years. So in the big climate models that they use to look at climate phenomenon, there wasn't a realistic representation of that. And as you start to help the models do that, they start to see things like, well, it really matters what altitude you do it. It matters like where towards the poles or towards the equator. And so they're just learning about that. And so it's not as simple as it sounds, but it's, kind of like, again, like a drug example, like, well, the efficacy profile of this one looks the most promising. However, there's also the risk side, the side effect side. And so what we know about stratosphere, putting things in the stratosphere, is that if a volcano goes off and things stay up there for a year or two, that's happened without a lot of complication or any noticeable complication. But what we don't know is if you want to do that for several decades, because what you're trying to do is keep the climate system safer and stabler while you're bringing out greenhouse gases. And so you need a longer period of time. Then there's some gnarly things that could come up that you really want to understand first. And so there's the ozone risk, which actually, investing in more research, you could really get more of your arms around that in terms of understanding like the chemical profiles and how they behave over time. But there are other things like when you reflect more sunlight off the stratospheric layer, you increase the heat up there in that part of the atmosphere. And that affects the way the lower and upper atmosphere circulate with each other.
Uh-huh.
And that can affect big things. And they don't really know quite exactly, whether that's significant, and if it is, what it means.
Right.
And so it's those kind of things like they call tail risks. It's like, for me, I want us all to know more about that. I'm not advocating we do this to totally understand this a lot better, or maybe we find out that there are reasons why we should never do it.
Well, so let me interrupt. Well, I think you're finished there, at least paused, so I'll jump in. Can we get to that point where we know or can be satisfied that the tail risks, that the potential heating of the regions above the stratosphere, I don't know, I get my ionospheres and stratospheres and the rest I need to look at it. But can we get to a point where we say, well, we're 60% certain or 70% certain? I mean, what's that threshold where we, I'm using the papal we now, that we say, well, we think this is the certainty is high enough that we're going to go ahead and launch jets and make this happen? How do we get to that decision point where everybody can say, yeah, we agree? Because again, international cooperation for CO2 emissions, the Paris Accords, I mean, let's be clear, I think they've been largely a failure, right? The countries are not meeting their commitments, they're blowing past them. I mean, they're going to grow their economies first. So how do we get that level of certainty or level of agreement to get something like this to actually happen?
Well, you've got a two-parter in there. One of the reasons I'm giving long answers, because you're asking more than one really good question at a time.
Okay. I make the big money, Kelly. So that's
yeah. So I'll say that I'll say provocatively and not too comprehensively that the CO2 problem is a much harder problem for the world to make decisions about, because it involves most sectors of the economy.
Sure.
And so in contrast, this is an area where, and we can talk more about it, there are likely to be very few actors who have the capability to do it. It's highly interfaced with governments even to get there. And so you're actually going to have a really small number of actors and a much less economic conflict around it than all the different incentive conflicts you have around CO2 reduction, which is really, really hard. So
So you're saying this is easier in some ways
As a
than trying to
decision problem, as we dug into it, because I started out, kind of where you are, just starting to look at into this 10 years ago, and then really active on the international decision making side over the past 3 years or so, and digging in and saying, here we go. So here's the dynamics. And so then when you dig into the Montreal Protocol, which governs these super pollutants, these more concentrated chemicals, so they have much smaller markets and fewer actors to deal with. They still have quite a few. But then you start to see, okay, so this problem looks a little bit more like this than it looks like CO2. And because you're going to have a small number of actors who can do this. And so not that there aren't complicated things to think about, but the big issue that you have with CO2, which is this direct conflict between people's life and livelihood in all these different ways, and their economic well-being as nations, you don't have that.
Okay.
And so in that way, what goes to your first part of your question, which is like, what is the information level that gets you where people might be able to reasonably agree? Now, we're a little bit Pollyanna about that because we're operating on the hypothesis that if you get enough information and you have people look at it together openly, that in this particular situation, kind of like with vaccines, although you'll tell me there are definitely still people who don't believe in vaccines, but that when you're in this kind of risk situation, and what the situation that you're in is you have to compare the projections under warming with whatever the only thing you're trying to do with these interventions is figure out, does this future look safer? That's it. And
so you think that decision-making process then for convincing international leaders. So, I mean, let's think about, the G7 or the G20, right? That you could get them to say, well, look, this is a lower risk pathway than business as usual. Is that a fair way to? It's kind of more of a binary assessment.
Or that's what you're trying to figure out, and not only like, is this safer than business as usual, or safer than the likely path that we're on, or safer than even the best possible scenario. In the best case scenario for climate change right now, in the UN, the climate continues to warm until 2050 in the best case. And most people don't think the best case is realistic. And so what we're trying to say is, what we want to be able to do is do a better job of projecting what that looks like. Because right now, the extremes and disasters that we have don't look great. Our water situation in the West, our storm situation in the East, all over the world, these extremes are happening. Currently, right now, in all projections for climate, that gets worse for 30 years.
Got it. Okay.
And so what we're saying is, okay, let's, do like we did with COVID and push research really hard to see if we can do better than that.
Got it.
And these are the candidates for that.
So I'm reminded in one of the questions when we first agreed to chat, I wrote down something that a good friend of mine, Chuck Spinney, who's been on the podcast, he was worked in the Pentagon for many years and was part of the lightweight fighter mafia. He helped design fighter jets. He was in the Air Force for many years. And he's always said that he's been skeptical of models, right? And just that his view is garbage in, garbage out, right? Whatever you feed in, you're going to get the thing out that you're after, the same garbage that you're putting in. And so he warned me too, very, very clearly about relying too heavily on models. But the question that I put here is the atmosphere too complex to model something like what you're talking about? Because I mean, there are skeptics around the climate change issue, right? About, it's too complicated. So it is complicated. There's no doubt about it. But you're adding another twist on this that says, well, if we do this, we'll have this result. And I guess as I'm asking that question, I'm wondering, well, is the science around the Mount Pinatubo eruption, is that robust enough to say, well, we know this from that in the 90s, therefore we can extrapolate that this X today will have a similar effect. So I'll just put that question to you again.
Yeah.
Is the atmosphere just too complex for us to really get an understanding of, and with a level of confidence that says, yes, let's go ahead and put these jets up there, balloons or whatever else that would achieve what you're talking about?
So that is an excellent question. It's very complex, super complex problem. And the first thing I'll say about it is the question that you're asking is not unique to these climate interventions. So the issue that we have is we can't currently project what the influences on the atmosphere are doing now. And we have these warming influences from greenhouse gases, and we also have these cooling influences from the aerosol particles coming out of pollution. And so we're saying, oh, these interventions shine a light on the fact that we have not been doing a very good job of that problem. And what's really interesting when you dig in is that, like, we've been investing really big amounts of money in emissions reductions and things. The investments in climate research in the United States and elsewhere have been flat for 30 years. They've not kept up with inflation. As a planet, we have not increased our investment in that question. And
In the overall investigation in climate change, you're saying?
correct. And the crux of climate change is exactly what you asked about, which is what things go in the atmosphere and how do you model and predict what's going to happen when they do that. And the two things we care about are the greenhouse gases that trap heat and the aerosol particles that reflect sunlight and push heat out. And both of those things are underrepresented in what we know. And so within climate research, the specific research on the atmosphere, including the observations, has actually declined in real terms. And in the United States, it's declined in real terms. And so the first thing that we're saying, and you're giving me a nice lead in because we have a report coming out next week, we're saying it's really important. Like if I'm telling you we think that putting aerosol particles in the atmosphere might help global safety. And I think that's something we need to know about. But if we want to do a better job of predicting whatever is going on and whatever happens when, now they want to suck, carbon dioxide out of the atmosphere or what have you, we've got to do a better job quickly of this same modeling complexity question about the atmosphere. And so we're saying that in the United States, to go along with all these other massive investments we're making, right now, today, we spend $3.5 billion a year on climate research. We have $55 billion worth of damage from the most recent 3 hurricanes, and that's just hurricanes. We just put $140 billion into, different emissions reductions and things like that. So we've got this really radical underinvestment in the information base. So yes, it's a complicated problem. But if you invest in it, it's not, it's similar to, we invest in, things that end up looking like ChatGPT or going to Mars or, it's a hard problem, but, vaccines are a hard problem. RNA science is a hard problem. We haven't really tried investing in it.
Well, okay, so let me just push back on that a little bit because if the investment in the vaccine, like the mRNA vaccines, Pfizer or the other companies, forgot which the other ones. So they invest in this, but they could see a real return on that money, right? They could make a lot of dough.
But the first research, there was a big portion of that was done by the government.
Oh, sure. But my question is really about, just a quick station break, just to remind everyone, my guest is Kelly Wanser. She's the executive director of Silver Lining. You can find out more about her at silverlining.ngo. She had a piece in The Hill in December talking about climate intervention. The possibility of some entity, though, you do this research, one of the problems, there are several challenges, I'll say it that way, is that if you find out, this works, there's no company. Who's the company that's going to make any money, right? It's different from the vaccine. This is where your emergency medicine comparison, I think, is not as apt here in that there's not going to be a company that wins. Oh, we got this, because what you're talking about in terms of the particulate, there's not going to be some private return to some corporate actor here. Or am I missing something?
No, you ask really good questions. And it wraps back to the conversation we were having a bit earlier about the credit idea. And there's a difference between whether there's an open market, credit type market, and commercial market in that sense, and whether this is a public good, and the market you might be looking at in the future are governments,
Right.
and people who make decisions about this and in favor of the public good. And you can think of things like different defense applications or nuclear non-proliferation technologies, or things that are effectively part of the government market.
Right. So that
And
it's a public good, but there's no private payoff, I guess, as I'm thinking about it, right?
for those things that are acquired by governments to provide to their people for the public interest, there's still commercial companies that do that. In fact, in the United States, the bigger spending is that on the defense side, right? And so they have one customer, which is the United States government, and however many $1 trillion we've got going. That's
I see. Okay, so it would be the climate intervention equivalent of Lockheed Martin or something like that, as a defense contractor they would make money for this, but it's not like a more public intervention such as vaccines, where there would be big profit. Well,
and even in the vaccine space, I mean, the government came in with a huge amount of investment and backstop. That
sure.
was not a pure, free market play. Their risk was totally mitigated. The government was the first buyer of the vaccines.
Okay, so that's a good point. So I think we've covered that pretty well. So let me switch a little bit and talk about what are here's the question I wrote down. What aerosols are showing the most promise? One that I've read about is calcium carbonate, which is something that apparently is pretty cheap. And whatever it is, that particle is going to have to be cheap, right? Because you're going to need many tons of it. So what is that compound that you're planning on using, and how much of it are you going to need?
Well, I'm going to, at the education, the scientists around me say, we're not planning on using anything. But of the candidates that people are looking at, I think what's been interesting in very recently in the past few years, when there's been, through some of our funding and a little bit of government funding, people looking at that question more closely. A lot of the theories around that were sort of back of the envelope map, based on what we know about the properties of this. And then when you get a little research going, you find out actually it's not quite that simple. And so scientists have kind of wrapped back to the sulfates still a little bit based on their early findings. But what they've really found out is that this is one of the areas, and there's a number of them, where you've got to do more research, because you don't have an answer to that question today. You really don't know.
So am I wrong about calcium carbonate? Did I make that up?
Yeah.
That's not one of the candidates. You're saying sulfates would be.
No, I'm saying it is one of the candidates,
Uh-huh.
but it's not something that people would say, hey, we know this is the best candidate.
But so the other compounds would be sulfates of some kind. Is there?
Sulfates, and also diamond dust.
I'm sorry, diamond
dust is one of the top candidates. Yeah. So
well, wouldn't that just when you say diamond, I think, well, that's expensive. Am I wrong?
Yeah, I'm not expert enough to know about the sort of classes of material and how they work. So as to whether that's a practical thing, but that is something that has come up as a candidate. And so what you want to do, and this is what hasn't been done, and this is where, I do want to emphasize for people, there is no technology. We don't know the answer to the question of what material you would use, what size those particles should be. Can we produce them at scale at that size? We don't know. And there's research you do on the ground in laboratories and chambers that could help me give you a much better answer to that question in a year or two, if we do it. And so that's exactly what we're saying as an organization, as like, there's some research you can define, there's a roadmap that, to your Air Force guy's question, okay, I'm not sure, how far we can get, but we can get a lot further than we are now in doing some of this research to answer those kind of questions.
Well, so then put a timeline on it for me, Kelly. Then what are, how many more years? Because this is one of the challenges always, right? And how long is it going to take to do something, some action? What is it going to be, and how long is it going to take us to get there? believe me, I understand climate change is a concern. It's not our only concern, right? That's my
Right.
stock answer, right? We have a lot of concerns and pandemics and war and drought and all and low and providing making sure we have enough low cost energy for people to not suffer, right? And providing
Right.
more energy to a lot more people. So one of the things that intrigues me about the climate intervention, climate or geoengineering idea is that it's it could be a way to prevent the potentially the worst possibilities of climate change, right? And for a relatively small investment compared to the size of the global economy. But what I'm hearing you say is that we still don't know enough, and we can't ring fence the ideas around which particles would work best, or even what types of stratospheric interventions would be the ones that would work the most. I mean, then you've also got, well, which part of the globe would you do the cloud seeding or crop dusting, right? Because that seems like another issue about, well, where do you do it and where is the most effective part of the globe going to be? Am I outlining on the most
Yeah, yeah.
difficult of
No,
the questions here?
you're asking the right questions. You're wrapping a couple of them in there, but because I want to take your point first, because I think we share really strong sort of philosophical sympathies with you about providing energy and having realistic expectations of what people around the world need and what they need to do. And that the problem that you're solving for is a problem of reducing suffering and improving safety. And you've got a situation right now where, in the best case scenario for climate change, you've got estimates of 1 billion people displaced. You've got a lot of places disappearing, like parts of Bangladesh, parts of South Florida, parts of Northern Africa. And so in that context, that's the context that you're in, where you expect those people on a day-to-day level to want energy, to want food, to need to try to improve their life. And that's the context that you're in. You can't expect the world economy to crash and for people not to try to have the things that they need to, live. And so in that context, then, what are our options for things to do, and how quickly can we figure it out? And so that's exactly the question we're aimed at, because I talked about what Silver Lining does, but the top thing that we do is we orient ourselves in time, and we wanted to figure out, can we be in a better, safer position within a decade? And in order to do that, we need to get a first order grasp on whether we have intervention options within 5 years. And so what we're putting forward in our report is a roadmap to say, what is the essential research you need so that the United States and the global community could look at these things and take a first order evaluation of where they sit. Think like vaccines or COVID treatments.
Sure. Yeah.
And take those top candidates, putting particles in the stratosphere, putting particles in the low atmosphere, and run that assessment aggressively so we can see where we are.
So are you finding, so let me read back what I think I see in terms of your challenges, right? And your risks, right? You have technology risk. You have, as an organization, you have capital risks, or your funder's going to stay behind you. But you've got a lot of political risk too, right? So, in terms of trying to convince policymakers to come on board and do what you want them to do, right? To agree. So 2 questions then. Are you getting traction within the Biden administration and here in the US? And then as you look at the other countries around the world, what other countries are showing the most interest or in cooperating on this kind of the kind of work you're doing?
Well, what we found is it really matters how you do it. And so we started very early in Silver Lining talking about these ideas with members of Congress in the US. And from the beginning, because we were talking about risk, because we were talking about uncertainty and some of the things that are already happening in the climate system, and we actually had bipartisan support for increasing the funding in some of the closely associated lines of research in the US government. So in the part of NOAA where they look at the stratosphere, and in the part of the Department of Energy where they look at the low cloud layer. And it was really based on the fact that if you want to answer questions, and again, it's not about saying, we want to do this and therefore we're going to start these active applied programs. It's about this is coming on to the scene as a topic because of where the climate risk is. And someone somewhere in the world is probably going to start to seriously consider these things. And we're the United States. We're well equipped to look at these questions. It's arguably some of the best resources in the world to look at it. And we like to be out front of these kinds of things. And so if someone somewhere in the world starts to pursue this seriously, we would like to know how we should respond. And right now, today, we don't have enough information to know whether it's good or bad.
So have you gotten money appropriated then in NOAA or in DOE then for this, that you can cooperate with scientists in the U.S. government?
In fact, yes. And so, for example, the NOAA and the Department of Energy released a report a couple of months ago, a joint workshop report on marine cloud brightening. I don't even have to answer your question because people go look at this report if they want to know what research is needed.
And is that report on your website?
It's on NOAA's website, but I will put up a link to it. I think there's a link, but I'll make sure that it's prominent on the website.
So you've got the challenge of educating the general public, the challenge of educating the policymakers, and then creating this constituency within science, among scientists, to push this kind of work to the forefront or the top of the list. So do you have a goal for the amount of money you want to raise this is your organization? You're operating on what, almost $4 million a year. Are you aiming for 20? Do you need 100? How much money do you need?
So thank you. That's a great question. Because for this year, we have a target of 7 million.
You want to double your budget from year to year.
Well, remember, we're making research grants.
Right,
and
sure.
So our operating budget year on year is about 3 million. And then we make research grants. I shouldn't say our aspirational operating budget is 3 million, right? But we've on average made research grants at the level of about 2.5 million a year.
Gotcha.
And so we're looking to modestly grow our own operating budget and significantly grow the research grant budget.
I see.
And because we've identified a roadmap of research, so we can say we have this portfolio of things, and the more research funding we have, the more we can move it along.
So one of the other things, and just a few more questions, because we've been talking for nearly an hour now. Why not direct air capture? I mean, when I look at I've studied the energy and power systems for a while, and one of the things I always think about is scale, right? That this is one of the most difficult issues, regardless of whether you're talking about inputs, outputs, managing carbon, whatever, that it's always about scale. And there's a lot of talk now about direct air capture or even post-combustion capture with net power and some of these other other technologies. But that's not your focus. Direct air capture, that's not what your focus is. The aerosol parasol, right? If I'm going to see that's really where you think the most potential is. Is that fair?
Mostly fair. I think I'm a portfolio person.
Okay.
And so I'm coming into the problem saying, there's a portfolio of things and they operate in different ways over time. And the portfolio gap that is there is the near term, the next 30 years or so, where the combination of the problem of scale and the problem of, how fast the atmosphere responds to bringing greenhouse gases out of it means that things like direct air capture are slower. And so by nature, and so we're trying to look at those things that say, look, if our safety profile in this 30, 40 year period or longer, if we do worse than predicted, at reducing greenhouse gases, warrants a more rapid response, what are the things that work rapidely? And so
you're arguing that direct air capture would just take longer because it would be more delayed.
It's a multi-decadal thing, and
I see.
Most of the
payoff from the seeding the stratosphere would be almost immediate then.
Yeah, so it's something
I see. Okay.
If you have the capability to do it, which we don't, but if you did, you could do it within a year or two. and
And
substantially cool the planet.
is Keith right that you would need then some sophisticated jet airplanes that would do this kind of
Well, it's an open question, and again, it goes to the question of the altitude and where you do it, as to whether, like today's current, you still need aircraft that are not common that can reach the stratosphere.
right.
But whether you need a new class of aircraft or you can use existing aircraft, like that's just still a question we don't know the answer to.
Sure.
So, but there is the question of, like, these are things that we need to pursue quickly to, to figure out if we want to understand it.
Well, I think it's interesting. One of the joys of my job is getting to talk to people and scratch my own itch on curiosity. And I've mentioned before on, what are my hurdles for this podcast? It's who do I think is interesting and who would I want to talk to for an hour? And because I feel if I'm learning, and people that might be listening get to learn as well. So this has been really interesting and getting some better ideas about what these technologies are, what the kind of the challenges are, and I'll be clear, as from my questions, you have a lot of challenges in front of you. So I wish you well with all of them, because you're facing a lot of complex challenges. But we've been talking for nearly an hour, and I want to make sure we stay on a good time frame. I mentioned that before we started, I asked my guests 2 questions. What are you reading? What books or magazines, or what do you have at the top of your reading pile?
Well, I have a lot of contemporary periodicals that I read to stay up with things, but recently I turned back to kind of a classic business book called Good to Great.
Oh yeah, Jim Collins' book. Yeah.
Yeah, and I think it affected me a lot when I was younger, and I've been turning back to it now, because it was written before the internet era, which really jacked up kind of the era of big personality leadership. And Good to Great is very much about low personality leadership, and this sort of team-based, more grounded kind of approach. And so, I think about that a lot, in terms of how you work on these kind of problems, especially because we work in a very networked kind of team-oriented way versus a big personality kind of a way. But it's a tough world to operate that way in. So it's a great book. If people haven't read it in a long time, I really encourage picking it up again.
Well, so then the last one, and I mentioned before, so what gives you hope?
So in Silver Lining, we work with early career professionals from different parts of the world in what we call our youth initiative, but most of them are in their mid to late 20s, early 30s, from Ghana, from Honduras, different parts of the world. And they work as members of our team, and they're really inspiring, and give me a lot of hope, because the ones that we work with, many of them have worked in the UN system. And they're much more diplomatic and effective with each other in their generation than we are in ours. So I'm seeing a lot of hope in the upcoming generation, that maybe they'll have some more civil and effective ways of working on problems like this. We'll see. But it's been really, really great, really inspiring.
Well, good. Well, I think that's a good place to stop. We're just short of an hour, so excellent. My guest has been Kelly Wanser. She's the executive director and the founder of Silver Lining, which is a nonprofit dedicated to ensuring that society has information and options to address near-term climate risk. And their work is focused on climate intervention, not geoengineering, climate intervention. Lots of interesting stuff there. I recommend you read her piece. It was in The Hill in December, which would give you a good primer on what she's doing. Kelly, thanks for coming on the Power Hungry podcast. It's been very interesting. Thank you.
Thanks very much, Robert.
And thanks to all of you in podcast land. Tune in for the next episode of the Power Hungry podcast. And if you have a minute, give us a rating, a 5-star, 12-star, whatever allows you to do on your local podcast outlet. And of course, on YouTube, do the same. Until the next episode, see ya.